Thank you all for joining. I'm super excited to be talking about this. This is something we've been thinking about, planning, working with prospects, working with the community for probably a year and a half now. And the most recent announcement that we made around Service Mesh Hub, like Betty said, is open sourcing these efforts. We've rebranded some of the efforts, and we're focusing on real use cases that people have when they adopt a service mesh, and especially when they adopt a service mesh in multiple clusters. And multiple clusters are multiple deployment targets, right? So you might not just run on Kubernetes. And so what we're going to look at today is what we're doing at Solo, and why we care about this, and why this is important. And then we'll spend most of the time on demos. I can walk you through some of the functionality that we have out of the box today, and point you to the community. So the stuff that we're going to be talking about is open source, and point you to the community, point you to the Slack, and so forth. And look forward to your feedback from there. So really excited to talk about Service Mesh Hub, talking about multi-cluster, multi-cloud hybrid deployment, application networking in a highly decentralized implementation that works well with cloud-based environments for microservices style architectures, and knowing that you can't just wave a magic wand and have a greenfield setting, knowing that you're going to have to imagine this within the constraints of your existing investments and enterprise. So with that, let's get going. I think Betty, you're on this slide.
Oh, actually, Christian, it's all you, because I need to run polls. Yeah, sorry.
Oh, tell me. All right, very good. All right. Then what, the foundation of this is like I said, we're looking at this through the lens of reality. You might be adopting Kubernetes. You might be modernizing your infrastructure. I had the great pleasure of working with Zappos.com back in 2012, and back then we were doing the same thing. We're modernized. We're going to, the parent company was Amazon. We're going to AWS. We're modernizing our infrastructure to work on the cloud and AWS and so forth. But the reality was not everything could go to those environments. So there was still the stuff that we had to keep in the data center on premises ourselves. And what we've seen since then, the last 8 years, is, through my work at Red Hat with customers adopting Kubernetes, and large enterprises, banks, and insurance, and health, and so forth, retail. The reality is people are deploying some new stuff to the new infrastructure. They're bringing some of the old stuff to the new infrastructure. They're looking at even newer compute platforms like functions as a service and so forth. But the reality is the platform, the deployment targets are hybrid. The technology that they adopt are of different vintages. They still have similar concerns, whether going to the cloud or deploying on premises, around keeping applications highly available, limiting blast radius, and identifying fault planes and keeping those as tight as possible. Being able to create options in terms of the vendors that they use and so forth, and using application architectures that allow them to select the right technology for the segment of the problem that they're trying to solve. So basically, it's a mishmash. The utopian, everything's just going to be one and highly, efficient, doesn't play out in reality. And so we want to keep this in mind as we go down this path. So what we've been looking at is, as folks adopt microservices, as folks adopt some of this new technology, and they start seeing new ways of implementing old problems and solutions, right? We are building APIs. We're exposing them to our users. We're exposing them to our business partners. We're maybe in some cases monetizing those. But more importantly, what I've seen is we're exposing them internally, and we're creating a marketplace internally to build new applications quicker and so forth. And some of the old ways of managing APIs in a highly centralized fashion doesn't play very well in this new cloud and modern infrastructure of highly decentralized, ephemeral, auto-scaling compute. Right, so things like service mesh started to come up and solve this problem a little nicer. And what we thought at Solo from back in fall 2018 is that this looks like something we've seen before. This looks like middleware and tooling that is going to be, there's going to be extremely fierce competition. There's going to be a lot of different incarnations and ways of thinking about solving these problems. What we think is going to happen over the next few years is there's going to be a proliferation of these types of technologies in service mesh. But what we want to do is help people adopt it, knowing the end of the story. We know that it's going to be difficult. It's going to be complex. It's going to be, you're not going to just be able to drop it in and start using it the way that the tool was built. It's going to be customizations and so forth. And so what we thought in 2018 and open sourced a open source project to kind of accompany this vision was, can we look at federating these service meshes and treating them as a single logical abstraction of the network, so that whether you're running on premises or in a public cloud, whether you're using one particular mesh or another, or just multiple instances of a single one, can we manage that in a unified way? And so that's what we started going down the path. That led to an evolution of the API, which led to our partnership and announcement with Microsoft in May. That led to innovation around extending the mesh. So if you have this API that can do things like traffic routing, collect telemetry, access control and so forth, you can write automation on top of it. So we announced an open source project called Autopilot it's basically an operator that you can write for orchestrating different service mesh capabilities. And then we know that the need for customization of these projects and these capabilities is high. And so we introduced WebAssembly Hub for making these customizations and modifications through WebAssembly. And then just recently, in April, we've rebranded Superglue, and we've kind of matured the capabilities of Superglue into an open source project we're calling Service Mesh Hub. And that's what we're going to talk about today. Now, just to kind of give a lay of the landscape, this is some of the data that we saw from people signing up for this webinar. So these are people who are potentially interested in service mesh, might be looking at it, might be running it, and the different ones that they're looking at. Now, this, upon seeing it ourselves, this reflects very similarly what we're seeing in the market with our customers, with our prospects in general. I would say this is fairly accurate. And I know, Betty, you wanted to run another quick poll.
Yeah.
You want to do that?
Yeah. So folks, we've got a little poll hidden here, as we've talked about just the service meshes that are out there. And now outside of AWS App Mesh, which is, in AWS, all these other ones can be run either on-prem or in the cloud. We'd like to just live now get some feedback from y'all on where do you plan to run your meshes? Cloud, on-prem, both? All right. I'm going to end the poll. We've got pretty much over 80% of the folks will share these. Can y'all see this? Hopefully so. But what we've got here is that, most folks are looking to run in the cloud or in both, and just a few saying that fully just on-prem. So this goes back to the point of hybrid, right? Whether you have even if you're planning to run your service meshes mostly in the cloud, you're still going to have a lot of other applications that are still running on-prem, what have you. And so effectively, everything is still hybrid. Now, and then we have one more quick poll. Quick question about your application architecture. So as you're looking at the environments, so your new environments for your microservices or Kubernetes apps, and things that the environments in which you plan to run service mesh, when you look at the architecture, are you looking at doing many small clusters? Or are you looking to manage them as mega clusters that are kind of subdivided? You know, there's different schools of thought on this. So this is, it'd be interesting to understand kind of how you're looking at this as you look at new applications and such that you're deploying. Pretty, all right. Thanks for the responses. So let me share the results. Interesting. So a small percentage have not yet decided. But then, you know, the many small clusters is just edging out. With the sample size here of respondents, just you know, just a few percentage points more than having few big mega clusters. So what's interesting here is that, you know, we're going to see this may even actually vary within your organization depending on how big your organization is and how many teams you have. Maybe for some teams it might be one, you know, a few large environments, whereas for other teams they may do many small clusters. So going back to the point of things will be hybrid within your organization. And so how do we go about managing that moving forward? Thanks for sharing that. Thanks for sharing your thoughts with us, and I'll hand it back to Christian.
Awesome. All right, let's get going. Let's start looking a little bit closer at the technology itself. So what we're doing at Solo, what we're very interested in is solving the problem of getting applications to connect to each other and do that reliably, do that in a way that we can observe them, and do that in a way we can control the traffic, and do that in a way that's secure. So what we see, the approach people take is they're starting to modernize their applications. They might be starting to use containers or Kubernetes. They might be starting to use microservices and starting to adopt patterns like the stringler pattern and so forth. And so for that, what we said is, you know, if you're starting to go down this path and you're starting to reimagine the way to solve API problems, do that incrementally and do that with the technology that's foundational to the way people are building these types of frameworks going forward. And that is with Envoy proxy and getting ready for things like WebAssembly. And so we built an open source API gateway called Glue on top of Envoy proxy to help solve those types of problems, those initial steps into this new world. Now, once you get there and you've built microservices, you're running in a cloud environment like a Kubernetes or in a public cloud, and you start to adopt things like service mesh, that stuff can get pretty complicated pretty quickly. And managing that across multiple clusters, doing things like routing across, failover across, unifying identity domains where necessary and so forth, and keeping all that running. I think that's the most important part. Getting it working the first time isn't the goal. You want this sustainable. So that's where we built Service Mesh Hub, and it's an open source project that we'll talk about today. And as I keep alluding to, none of these things are built with the assumptions of your organization in mind. So you'll need some way of integrating it with the rest of your processes and your workflows. You'll need a way to change the behavior of the data plane at runtime to handle things like non-standard security requirements and protocols. And you need logging to be just exactly the certain way that you have it in your environment, or any number of these customizations. And so that's why we're focusing our efforts on WebAssembly. That's why things like Glue in a non-production way right now, at least, supports WebAssembly. We're seeing, we help contribute to the developer experience to running WebAssembly with Istio and so forth. So the entire spectrum of getting Envoy-based technology and frameworks working in your environment, regardless of what your environment is our core competency at Solo. That's what we're working on. And doing that in a decentralized manner, right? So we're starting, we want to go faster. That's the whole point of doing something like microservices and adopting self-service cloud platforms, is to be able to go faster. So we need a way to decentralize our APIs and decentralize the way we implement, the things that we're building. So for example, I mean, you start looking at deploying your services into a cluster or multiple clusters. You need some way for the traffic to get in. You might want to manage the evolution from monolith to microservice. And so Glue fits in at the edge of your application boundaries to solve things like security, things like OIDC, web application firewalling, data loss prevention, TLS termination, and so for those types of security concerns, rate limiting, message transformation, automatic service discovery, and so forth, right? So Glue fits in that particular part of the puzzle. It is an open source proxy for which we do have an enterprise commercial support and product for. But what it is it's Envoy with a fairly simplified control plane that is decoupled from the proxy itself. So you can run it separately and scale it separately and secure it separately and so forth. It looks a little bit more like this, where we have Envoy. We've built in things like data loss prevention and WAF and transformation and so forth into Envoy, and the control plane can manage that. And you use CRDs in Kubernetes or YAML configs outside of Kubernetes to run and manage your Envoy. But like I said, this is in this hybrid world, you'll probably likely be running on maybe Kubernetes, maybe VMware, maybe AWS in the public cloud or some of the other public clouds. And you need a decentralized way of solving these edge ingress type problems. And so that's where Glue can also fit, right? So we can, we have coverage from Envoy capability at the edge, regardless of the platform into which you're deploying or where your applications live. Now, when the services start to need to talk with each other, and we need to solve for this east-west traffic direction, that's where a service mesh would come in and help. The service mesh gives visibility to the network at the application layer. Things that we've always wanted in the past. So we might have put ESBs and message queues and so forth in there, thinking that we just have this nice centralized hub where everything flows and we can see it and control it and so forth. This model is a little bit different. The implementation is highly decentralized. Envoy is running next to each of these workloads, whether that's in containers or in VMs or anywhere physical. And all the traffic is flowing through these Envoy proxies that have been deployed next to our applications. And they provide things like timeouts and retries and circuit breaking and telemetry gathering and security for end-to-end mutual TLS and so forth, because the transport goes through these proxies. And then the service mesh gives you a control point in terms of the data plane as well as the control plane. So the service mesh gives you a single place where you can go configure the mesh. And the problem that you run into is now, how do you start to do that and federate things across multiple of these deployment targets, multiple of these service mesh control planes? And that's exactly the problem that Service Mesh Hub was built to solve. Now, we're also aware that, for example, maybe Istio today might be, more highly adopted and so forth, at least based on the polls that we've seen, the anecdotal data we have. But we realize that when people go to a public cloud like AWS, for example, AWS has a service mesh, and it's actually getting, first of all, it's getting good. It works across multiple deployment targets. So ECS, EC2, EKS, and I think Fargate and so forth. So using AWS App Mesh in Amazon, which is free, and it can be used across multiple of these deployment targets, is actually a pretty sane idea. Even if you might be running Istio somewhere else, maybe on premises or maybe in different cloud. And so we're going to see this adoption pattern. And if any architect is, been around for a little bit and seen the evolution of enterprises, you know that you don't have one of anything, right? You have multiples of everything. And it's unfortunate, it's not ideal, but sometimes it's miscommunication within an organization. Sometimes it's through merger and acquisition, but you end up with multiple incarnations of a particular technology solution. And like I said, shouldn't be something that you strive for, but in the event that does happen, at Solo, we're building Service Mesh Hub with that in mind, with the reality, sometimes ugly reality of the enterprise, the collection of software and solutions that they end up having. So Service Mesh Hub is a multi-mesh management plane for multiple clusters or multiple deployments of a service mesh. And the goal of it is to unify those different deployment instances so that you as an operator, as an SRE, can think about the platform as a whole and not each individual mesh's API differences and conflicts and whether one mesh can talk to the other, whether the identity is unified, keeping things like service discovery up to date, and so forth, and doing this across any deployment target or any mesh. And so that's what we're targeting, and that's what we're building with Service Mesh Hub. So that's enough talking. Let's actually look at Service Mesh Hub. I think the first place to start is a web browser, actually. Just bring this over here. If you go to docs.solo.io and /Service Mesh Hub, you'll get to the docs. And I think this is a great place to start. The getting started is well named. and so this will get you on your way. If you want to look at GitHub, we can see the open source project here. It's very active. We do frequent releases. We just updated some documentation for contributors to contribute to the project and so forth. Join Slack if you have questions and issues. But so basically what Service Mesh Hub looks like is this. So the first thing that we're going to do is we have multiple clusters here. Let me just actually come over here and make it a little bit clearer. All right, we have multiple clusters here, and one of them is named the management plane, one of them is called remote cluster. And we have Istio installed on each of the clusters. We installed Istio independently from each other, and we're running independent Istios at the moment. What we're going to do in the demo is we're going to install Service Mesh Hub on one of the clusters and register those Istio control planes with Service Mesh Hub. Now, this is purely just to save in the number of clusters that I have up and running, but we could, and you would ideally do it like this, where you have a separate cluster for your management plane, and you would be managing the remote clusters. So let's take a look at that. So this is a live demo, just cautioning you, setting expectation that it could fail, but we'll cross our fingers very tightly. So we can see in cluster number 1, the management plane, we have an Istio running. This is Istio 1.5. As you can see, Istio D is the evolution of the control plane in Istio. We also have the ingress gateway here and a DNS component here. We are expecting the same setup from the remote cluster, our second cluster. And just to get an idea of how we installed Istio here, if you come to the docs, under guides, and installing Istio multi-cluster, with Service Mesh Hub, actually we could very quickly install a multi-cluster ready service mesh, or Istio, which controls which components. Ultimately, under the covers, it does set up the operator and so forth. But just from meshctl tool from Service Mesh Hub, we can very quickly spin up Istio like I did here. So in the first cluster, we can see we have some components of the book info app. So this is the sample from Istio. running. We have version 1 and version 2 of reviews. On the second cluster, we have some of the components from the book info app running. We have version 3 of reviews. And so the first thing we're going to do is install Service Mesh Hub into the management plane context. We come back here, that will be so that the architecture looks like this, where we have Service Mesh Hub running on the management plane. It looks like that's been installed. We could very quickly take a look at what components make up Service Mesh Hub. And right here we can see that we have the discovery and the networking components. And I might jump back and forth here. If you click on operations and the troubleshooting guide, we do give information about what those components do, debug them, and so forth. So I just want to point that out. So we have those two components running. This makes up the management plane. What we're going to do is check to make sure that everything was installed and everything looks correct. And that does look good. Okay. Now let's register. So we have the management plane installed. Let's register our clusters with the management plane. And so what this is going to do is tell the management plane, Service Mesh Hub, about cluster 1 and about cluster 2. And then what Service Mesh Hub is going to do is go discover what is running on those clusters. Which service mesh is running, if there is one. Is it Istio? Is it AWS App Mesh? What is this? What workloads are running? What services are defined for those meshes? So we'll go basically kind of build a map of or the lay of the land of the different deployment targets, in this case clusters, that we have access to. And we should see that the clusters were correctly registered, and we should see that the different meshes were also discovered. So we have Istio running on cluster 1 and cluster 2 here. So that's great. Now what we want to do, we have these two separate meshes, right? We have these two separate meshes. Service Mesh Hub is running on one of the clusters. What we want is to enable some service discovery. We want to enable a root shared trust between the two meshes without doing unsafe things like exchanging private keys and so forth over the network. So what we want to do is establish a unifying construct across these two meshes, in this case, these two clusters, so that we can start to treat those two meshes as a single virtual mesh, as a single logical mesh. And so to do that, let's take a look at what the certificates, what the identity of the meshes are, and then let's unify them and unify their capabilities as well. So what we did here in this command is, in the first mesh, we just made a simple call between reviews and ratings. And we're asking the OpenSSL client to show the certificates. We want to see exactly what is the root identity for the MTLS in cluster 1. We see this one looks like the certificate ends with UHC. Let's do the same thing on cluster 2. And what we should see is a different root on cluster 2. It should be a different ending. It shouldn't be UHC. And in this case, we see something different indeed. So M+2 we see. So different roots in the two different clusters. What we're going to do is we're going to use the Service Mesh Hub virtual mesh CRD to establish a shared trust domain and shared root CA. In this case, we're going to automatically create the root, but we could use a provided one, and that provided one could come from Vault or some secret store and so forth. We're going to federate them with the service discovery capability of permissive. This just means that we're going to let all of the services from one cluster know about the services running in another cluster. So these things can be configured. We're going to start with access control false. So we're just going to enable all the traffic. And then we're just going to group these two meshes that we've discovered. So let's do that. Let's apply it to the management plane. And what this is going to do under the covers is start to orchestrate unifying their trust domains, orchestrate their service discovery, and give you the opportunity to treat these different clusters as a single unified mesh. Hopefully, let's see. So let's use mesh check one more time. Cross our fingers. It looks like the little green check marks didn't show up. I can live with that, but it says there are no errors. So that's a good sign. The next thing we're gonna do is actually look at the CR itself, and we should see that. So first of all of the CRs in Service Mesh Hub have a status field. So you can very quickly, using your own automation, your own tooling, determine the state of these resources. And we can see that the certificate unification has happened. The access control, which was set to false, it has happened. And so has the service discovery for federation. That all looks good. So now let's take a look at what we did. The first thing we did was we created a root private key insert pair, right? In the management plane. It's called virtual mesh CA certs. If we come back, let's just come back to our diagram real quick. What we did was we built this part. You can see in the diagram, we built this part. S certificate ends with QS and an equal sign. We'll try to remember that, QS and an equal sign. If we look at the remote cluster, the remote cluster has something called a virtual mesh certificate signing request. And so what it did in the virtual cluster is it spun up a little CSR agent. That CSR agent created a private key insert pair local to that machine. Nothing was transferred over the network. And then the CSR agent said, hey, Service Mesh Hub, I have a certificate signing request. I want you to sign this with your root so that we can use this new certificate as intermediate CA for Istio. And therefore, Istio can then, any of these Istios on both sides, both clusters, can use this intermediate to build the workload certificates that all derive from the same root. So we have a shared root CA. So if we take a look at that, we should see, if we get the certificate signing request, we have, we see the CSR data. It's base 64 encoded, so you won't be able to see it very clearly right now. But like I said, all of the CRs have a status field, and we can see that this was accepted with a particular certificate using a particular root. All right, so that looks good. Now, let's take a look at what we've done on the remote cluster, or for both of the Istio service mesh control planes. We've created that intermediate on the management plane. We've done the same thing for the remote cluster. So that is this part. We've created this intermediate, and it's signed by the shared root. Now, because of a workaround we need to, that we're going to fix upstream, we want to restart the Istio control plane so it picks up this new intermediate. We'll give that a second. We'll do that on both sides, the remote cluster and the management plane cluster. And then one thing you'll also notice is that for the demo, I also restarted the book info pods just so that they would pick up their new workload certificate faster, just for the demo, so we're not sitting here for however long it takes for that to happen. And then now what we should expect is both control planes now are using a CA that share the same root, so that if we run that same command that we did earlier, reviews calling ratings and exploring their certificates, we should see their root CA. The root certificate is QS equals, I believe that's what we memorized. But if we look at the second cluster and make that same call, QS equals is what we're looking for, we should see the same root and the same ending, QS equals. So we can see now that the roots have been unified. We have a shared identity between these clusters. So one thing that we can do with that now, once we have this shared virtual mesh, what we can do is write rules to enforce certain traffic behavior or access control behavior across the different meshes without having to go to each mesh and specify them independently with this implicit link between the two and so forth. We're doing it very explicitly, and we're doing it with a API that is virtual mesh aware and therefore multi-cluster aware. So if we come here, we see that we're going to actually go to the book info demo now. So if we go localhost 9080, a normal user, that's our fingers. We see we have the black stars, and we should see we have no stars. So this is version 1 and version 2 of the review service that's being load balanced here for the book info demo. So what we're going to do is we're going to enable our access policy or turn access policy on for the mesh. So we're going to take the same virtual mesh, we're going to change that one flag to true, and it was false. We'll change it to true. So let's apply it now. And what that is going to do is enable access control policy, which by default out of the box has a deny all policy. So we should end up seeing, and it does take a little bit for this to trickle into the Istio control planes. What we should see is at some point, things start to become unavailable because the call cannot complete. We start getting errors here because the product page can't call its collaborators, and those services can't call their collaborators. We refresh a couple times, we see now everything has come to a grinding halt. There's no traffic flowing because there's no access policies. Right. So let's take a look at a access control policy from Service Mesh Hub that gives you as much fine grain or coarse grain control over this policy for the virtual mesh, treating this as these two clusters as one single mesh. And so what we're gonna say here is for product page in cluster 1, trying to talk to a service that lives in a namespace of default on any of the clusters, allow that to happen. Allow product page to talk to reviews and details and so forth. So let's do that. Let's apply that. And so that has been applied. Now, if we refresh, like I said, it takes a second or two, we see that the book details has come back. We see book reviews has come back. So we enable the traffic from product to some of its direct collaborators, but from reviews calling ratings, that is not enabled. So let's enable that. Let's enable calling from the reviews service to call into ratings. So allow that to happen. We should eventually start to see the same behavior that we saw. So here's reviews V1. We should see reviews V2, load balance in. Okay, very good. Next, the last thing that we'll look at is that same idea, having a unified configuration API for controlling access policy. Let's do the same thing with traffic control and traffic routing. So right now, the first thing that we'll look at is the federation model we set to permissive just made the services available on each of the different clusters. So on cluster 1, I can see I have access to the service is running on cluster 2. If I do the other way, on cluster 2, I should see the ones running on cluster 1. So these are the service entries that Istio uses to be able to route traffic outside of the mesh. If we take a look at one of these service entries from cluster 1, let's say, we can see that we've defined a host of workload.namespace. Whatever the cluster is, and we're pointing it to an external address somewhere. Now that external address in the Istio model is the Istio ingress gateway for cluster 2. So if we talk about traffic going from workload to this cluster, the traffic will go from the workload into the remote cluster's ingress gateway. And if we actually look at the ingress gateway on the second cluster, we should see that those IP addresses 183.14 matches what we expect on that ingress gateway on the second cluster. So let's look at the traffic routing API. So again, this is just like the access policy API, but it is virtual mesh aware. And what we're going to say is, in this case, split the traffic or control the traffic so that 100% of it goes to reviews v1 on cluster 1. We can apply that. At this point, we're still just dealing with it happens to be the workloads on a single cluster. So if we refresh, we shouldn't see the black stars anymore. Now, if we split the traffic between v1 and v2, we should see that just fine. Then we should see load balance. 75% of the time we should see this, 25% of the time we should see the black stars. And then we could also say, let's route a majority of the traffic to cluster 2 review service, which is where reviews v3 lives, and lower the percentage of the routing to those in cluster 1. We do that, and we refresh. We should see, most of the time, we should see the red stars, because that's v3 of reviews, and we do. So from this traffic policy, we can control the routing of the traffic in our system without having to know exactly, go to each one of the clusters and manually configure them, right? So we have a policy that's aware of this virtual mesh. Now, one thing that can happen, so okay, we'll take a quick look under here. We'll follow the script. What's happening under the covers is the Service Mesh Hub is orchestrating Istio, and Istio is creating its known API under the covers. Right, so we can take a look at the virtual service, and it knows how, it knows the Istio API here. But one thing that can happen when you're building these policies across different clusters is, for a particular service, you might not know exactly, just by looking at the configs, what are the rules that apply to that service. So although we give you a nice, as fine grain and as coarse grain of routing rules as you need, you can also just look at a particular service and say, all right, what are the rules that apply to this service? So we eliminate any type of confusion. In this case, we can see if we ask about the review service, we have a traffic shift policy in place. But you could also have various header matching policies, or fault injections, or retries, and so forth. And as soon as you start to come up with, let's say, a hierarchy of rules, something that you might say is default for all of the services, maybe, I don't know, retry of 2 or 3 or whatever, you might have more fine-grained rules at different layers, and those all get merged together, but you can still see per service what applies to that service. So that is the end of the demo. We'll leave you with links to Service Mesh Hub. In the community, definitely go to Slack if you're interested in this and interested in contributing, interested in kicking the tires of trying this out. Please go to GitHub. Please go to the Slack, sign up, reach out to me, reach out to anyone in the Slack Graham and Harvey and Eitan, you've all know those folks, the engineers at Solo, we'll be more than happy to help. If you want to reach out to me directly, absolutely feel free. I'd love to hear your feedback. And I've left a little bit of time here for some questions. So
yeah. So we've got there's one actually that's a glue question that if we could answer that, and then we can get the others.
For some reason the Q&A on Zoom is not popping up for me, so I can't see the questions.
Okay, I can read it for you.
Okay.
There's one here. It's like, can Glue act as an interface to redirect to different clouds, cloud application services like AWS?
Yes.
Okay.
Yes. So with Glue, we can, the backends that we route to, first of all, out of the box, Glue will do its best to discover the services that it can route to. So for example, if it's running in Kubernetes, it will query the Kubernetes API. If you've configured it with console, maybe you have Kubernetes and console, we can discover things running in console. You can also point it to AWS, and it can automatically discover workloads that are running on EC2 or in Lambdas. And the foundational piece to the Glue control plane and even Service Mesh Hub is that everything's built on plugins. So if there's a registry or you want to do some automatic registration using a registry that we don't have support for at the moment, so maybe something like Zookeeper or whatever, that can easily be added and extended into the control plane. But if you don't want to use the auto discovery, you can statically register these different services into Glue. So Glue can be used for all kinds of cross-cloud routing, cross-zone routing, and so forth. Kind of like I think I pictured that here, right, in one of these. Next question.
Is the Trust Federation built on or an implementation of SPIFFE or Spire Federation?
Yeah, that's a great question. So the identity model at the moment that is being used to federate the identity between the meshes, as we saw in this diagram, is based on the underlying meshes implementation of identity. So in this case, it is Istio, and Istio uses SPIFFE. Now, what becomes even more interesting is when we get into situations like this, where we have maybe Istio and app mesh running, or Istio and Linkerd, or console, right? So now when we start to federate those, there's going to have to be an exchange and a transformation of identity and trust. And so that's something that we are building out in Service Mesh Hub.
Another question here is, in the demo, is there MTLS between the workloads and the two clusters?
Yes, that's a great question. And the answer is yes. So MTLS is enabled. And like we saw, if I can maybe scroll back up, let's end this thing. If I can maybe scroll back up. So the call on cluster 2 from reviews to ratings had a root certificate of QS. It terminated with a certificate of QS equals sign. The certificate on cluster 1, when we called reviews and ratings, also had a root terminate with QS equals sign. So they're both part of the same root trust domain. Now, Istio was configured to use MTLS, as we can see when we make these calls. So that's when I called asked to show the certs. The mutual TLS is happening between the applications in their own individual clusters. But when they go across clusters, since they share the same root and they go over to the other cluster's ingress gateway, that does a little SNI routing directly to the workload. The MTLS is uninterrupted. So it's end to end from the workload in cluster 1 to the workload in cluster 2. So yes, answer is yes.
And what kind of network requirements are required between the two clusters for the flat network? Or do they just need to be able to access the gateway?
So that's a great question. In this particular model of multi-cluster, we went with an assumption that there was no flat network. These were different networks, but the gateways, that we could reach the gateways. So there was connectivity to the gateways. There are other models that you can do multi-cluster, and maybe this would be a good webinar, is just to do multi-cluster patterns and trade-offs. But where we can go in a little bit more detail about the different architectures and the pros and cons. But you could have a scenario where in your network, you do have a flat network, and you do have multiple clusters and workloads running within that single network. And you might want workloads to be able to directly connect to each other. And that's a valid approach as well. And you might want the control planes in that case, instead of be completely separate, maybe to be deployed in a highly available scenario where you have only one active and one for failover. And so there's a bunch of different models here. But in the demo that I showed, there was no assumption for flat networking, but that's not the only approach to doing multiple cluster and federation of Istio clusters.
So then that actually, there's a quick question here. I think you bring up a good point. We're going to have a whole nother session just on the multi-cluster patterns. But question here is, other than traffic routing, can you touch on what are some of the other use cases for like a federated mesh or kind of these multi-cluster patterns?
Yeah. So to be able to do, or the reason to federate them, is that the question?
Yeah.
So the reason to federate them is to simplify the operations of them. Is to enable things like failover, enable things like global discovery, service discovery, enable things like global mutual TLS, like we saw, to enable like a unified single pane of observability, so you can see what's happening across the different clusters. So the answer really is just how do you do that, and how do you simplify that and make that operational and have that ready for day 2 type operations? Because like I said, the individual meshes, look at Istio, you can go follow the steps for doing this stuff. But then making it operational, making it repeatable, making it part of your CI/CD platform, and doing it in a way that kind of lowers the mental acuity that you have to understand what the heck is going on. I think that's what we're doing with Service Mesh Hub. Those are the advantages of deploying across multiple clusters.
And I think the last question that we'll cover today here is, in terms of like an HA type of scenario, can and should the hub be replicated? So the management plane itself across clusters, or what do you?
So the hub itself would need to be, so at the moment, it doesn't, we don't, the hub itself, the management plate is not highly available. Now you could do it. You could do it pretty easily, but it's not something that we've tried to simplify or make it possible yet. But the interesting thing about that is, and I get the pros and cons about it, but the interesting thing is, if the management plane were to go down, each individual service mesh, still, at least in the model that we looked at today, has its own control plane. Right, so those are still up and running. You've limited the blast radius of a failure here into each of the different zones, the management plane zone and each mesh control plane zone, right? So everything would still continue to run. You could still operate it. You might have to go to each one of the meshes, but ideally the mesh management plane would be deployed in a highly available scenario. Now, why I said you could probably do it today is, the way you might run Kubernetes today. I know some people might run Kubernetes in an HA scenario where you have a hot-cold scenario where you have a cluster running, and then you have one standby, and so forth. The model I think that would be appropriate, that we're going to probably end up with, is you could run 2 active, but only one is the leader and the other one's the follower. So we're still ironing out exactly how we want to solve that. But I would say right now, from because it's the management plane driving these other control planes, the fault zones still exist in such a way that you don't get cut off from using, or things don't start to fail because the management plane goes down.
Cool. So that's we are at time. There's a few other questions in here, but what we can do is we can answer them offline.
Yep.
Get back to folks. We'll post that with the recording and the slides as well, and also recap some of these questions in there. And we look to have everybody in the Slack channel. Christian, if you want to go back to that last slide.
Yep.
Slack.solo.io, and pop in there with your questions. And also we've got the link to the GitHub repo. We'd love to have you take a look at the project, participate, give us feedback, file any issues or PRs, that'd be fantastic. It is open source. And we will see you next time for the next webinar. Thank you all for joining.